Bismillahir Rahmanir Rahim. In this topic, we are going to discuss the techniques of differentiation. In the last part, in the last topic, we found the derivative of given functions using the definition, and we said that f prime of x equal to the limit of f of x plus h minus f of x divided by h where h equals to 0. And we call that the definition or the first principle for a function, or for the derivative of a function. In this topic, we are going to discuss the techniques of differentiation. We have in this slide 3 rules for the differentiation. The first one, the power rule. The power rule says that if R is an real number, then the derivative with respect to x of x to power r is equal to r multiplied by x to power r minus 1. Because this is the power rule. Second rule, the constant multiple rule. Constant multiple rule. And this say that if we have a differentiable function at x, say that f is differentiable at a given point x. At x, and c is an real number. Then the derivative of dx of c f of x is equal to, we can take the constant outside and multiply it by the derivative of the function with respect to x. Third rule, sum and difference rule. This rule says that the derivative of sum or difference between two functions, f of x plus or minus g of x, is equal to the derivative of the first function plus or minus the derivative of the second function. This is the sum and difference rule. So the derivative of the sum of the two differentiable functions at x is equal to the sum of their derivatives, f prime plus g prime. These are the 3 rules for this part, and I'm going to give now some examples to explain these rules. Find the derivative f prime in each case. Number 1, if the function is equal to 2. It's just a constant function. F of x is equal to 2. In the last part, we said that the derivative of a function is change of rate of the value of the function. It is change of rate. If we have constant function, say that this is 2. Constant function, this is f of x equal to 2 or y equal to 2. You can see there is no change in the function. It is constant, keeping the same value from minus infinity to plus infinity. So there is no change. If I want to calculate or to find the derivative using the definition, which is f of x plus h, f of x plus h in this case is equal to 2. By the definition, this is equal to 2, which means f of x plus h minus f of x is equal to 2 minus 2, which is equal to 0. The limit of 0 is equal to 0. So if we apply the definition, I will have 0. So for any constant function, if we have constant function, this is constant function, the derivative f of prime of x will be 0. So the derivative of a constant function is equal to 0. We have to keep this in our mind. The derivative of the constant function is equal to 0 for any real number. Number 2, f of x equal to x. It is x to the power 1. No, power means x equal to power, x to the power 1. Now if you apply the power rule, f prime of x equal, the power is equal to 1, so it is 1 multiplied by x, it is r minus 1. The power minus 1, which is equal to 1 multiplied by x to the power 0 is equal to 1. So we can say in general for the linear function, for any linear function, x to the power 1, the derivative of that part is equal to the coefficient. The coefficient is equal to 1, so the derivative in this case is equal to 1. So if the function f of x equal to 3x to the power 1, then the derivative in this case f prime of x equal to only the coefficient. It is equal to 3. The derivative of x to the power 1 is equal to 1, so we can take the coefficient outside, and that will be the derivative. Number 3 or number 4. F of x equal to 5x to the power 3. 5x to the power 3. The derivative for this one, I can apply the two rules, the constant multiple and the power rule. So the derivative for this one, f prime of x equal to 5 multiplied by the derivative of x to the power 3, applying the power rule, it is 3 multiplied by x to the power 3 minus 1. This is the power rule. Writing the power down and subtract 1 from the power. It is x to the power 3 minus 1. And I will have 5 multiplied by 3 is 15, x to the power 2. It is 5 or 15 multiplied by x to the power 2. One more. F of x equal to 2x to the power 3 minus 4x plus 3. Now I have 3 terms. It is like I have 3 functions. To find the derivative for this one, I need to find the derivative for each term here. Now the derivative of the first part for the first term is equal to, think about this one. It is 2, the constant multiplied by x to power 3. Write the power down. It is 3 multiplied by x, 3 minus 1. Subtract 1 from the power, I will have 2. So it is 2 multiplied by 3 multiplied by x squared. Now we are done from the first term. Let's move to the second one. Second term, minus 4x. It is x to power 1, so the derivative will be only minus 4. Minus 4 multiplied by the derivative of x, which is equal to 1, so it is minus 4. Now the derivative of the 3 is constant. The derivative of the constant is equal to 0. This is the derivative of 3 is equal to 0. So the derivative now will be 2 multiplied by 3 is 6, x to power 2 minus 4. This is the derivative of 2x to power 3 minus 4x plus 3. So we are differentiating or find the derivative for each term. We differentiate each term in the function. The first one plus derivative of the second one plus the derivative of the third one. Number 6. F of x equal to, let's say, x to power 3 plus 1 over x to power 2. Let's find the derivative of this function. But let me just rewrite it in a good way. So the derivative of f of x, or the function itself, is equal to x to power 3 plus 1 over x squared. I will write it as x to power minus 2. So it is x to power minus 2. And the derivative for this one is equal to, applying the power rule, it will be 3 x to power, this is minus 1 there, 3 minus 1 is equal to 2. So this is a 3 multiplied by x squared. Second one, minus 2 with minus 1. Or just deduct 1 from the power. So the power itself will be written down as minus 2. The power will be written down, multiplied by x to power minus 3. So it is 3x squared minus 2x to power minus 3. Number 7. F of x is equal to, let's say, x to power y plus 2 square root of x. Let's find the derivative of this function. I have x to power y. Y is just a real number, irrational. It is irrational number. So I have x to power y. Since it is power, we can apply the power rule. But before doing that, let me rewrite the function again as x to power y plus 2. Square root of x can be written as x to power 1/2. Square root means x to power 1/2. So the derivative of this function now is equal to, this will be by x to power y minus 1. As we said before, this is power, apply the power rule, so it is minus 1. It will be x to power y to power x to power y minus 1. Now the second term, keep the constant 2. Now the derivative of x to power 1/2. Again, there is minus 1 there. Write the power down first, which is 1 over 2. X to power 1/2 minus 1 This is 1/2 minus 1 is equal to minus 1 over 2. So this is minus 1 over 2. So again, the power now, or the derivative, is equal to by x to power by minus 1. 2 will cancel with the half, so it will be plus x to power minus 1/2. And that's it. This is the derivative of the given function. So just applying the techniques of the differentiation, it is straightforward. We take one more. That will be number 8. F of x equal to minus 3 x to power 7 minus 2 x to power minus 5 plus third root of x minus or plus 10. Let's find the derivative of this function. Since I have third root of x, just let me rewrite that part. So the function again can be written as minus 3 x to power 7 minus 2 x to power minus 5 plus x to power 1/3. Third root means x to power 1/3 plus constant 10. Now let's find the derivative. The derivative for this one is equal to the coefficient minus 3 multiplied by the power minus 1 from each power. From each one, we will deduct minus 1, applying the power rule. So the first term is minus 3 multiplied by the power to power, or multiplied by x to power 7 minus 1 is equal to 6. Second one, minus 2 multiplied by the power, and x to power minus 5 minus 1 is minus 6, plus power down 1 over 3, this is third, x to power 1/3 minus 1 is minus 2 over 3, plus derivative of the constant is equal to 0. Let's write it just to remind you that the derivative of the constant is equal to 0, which is equal to minus 3 multiplied by 7 is minus 21 x to power 6 plus 10 x to power minus 6 plus 1/3 x to power minus 2 over 3. So this is the derivative. This is the derivative of the given function. So it is just easy, straightforward to find the derivative of a given function. One more, that will be last one. F of x equal to square root of 2 divided by x plus square minus 3 divided by x. Let's find the derivative of this function. Sometimes we need to simplify it or rewrite it in a very nice form so that we can find the derivative. Now this function can be written as square root of 2 divided by square root of x. I write it step by step, plus the second part, it can be written as x to the power minus 1 multiplied by x squared minus 3. Again, this is square root of 2 multiplied by x to the power minus 1/2. Square root down in the denominator, we can write it as x to the power minus 1/2. For the second term, or second part, open the bracket, it is x to the power minus 1 multiplied by x to the power 2. And for the multiplication, we add the powers. I will have x to the power 2 minus 1 is equal to 1. This is the first term. Now go for the second term, minus 3, x to the power minus 1. Now I can differentiate. Keep in mind, in each power, we take minus 1 for the derivative. So the derivative of this function now, f prime, is equal to square root of 2, keep the constant. Now multiplied by the power is minus 1/2, multiplied by x to the power minus 1/2 minus 1 is equal to minus 3 over 2, plus the power is 1, x to the power 0, which is equal to 1, minus 3 multiplied by the power minus 1 multiplied by x to the power minus 1 with minus 1 is minus 2. So this is equal to minus square root of 2 divided by 2, x to the power minus 3 over 2 plus 1 plus 3 x to the power minus 2. And this will be the derivative of the function.